we want to look at how we can integrate some complex trig products. So we call this complex trig integration, and we're going to have to use some minor trig identities. We don't deal with a lot of identities in this course, but there are a few trig identities that we need to be comfortable and familiar with. So the first one is the Pythagorean identity, and we actually have 3 of these, but right now we're just going to focus on the sine and cosine. So sine squared of x plus cosine squared of x is going to be equal to 1. Now we also want to make sure that we understand that this can be manipulated, because most of the time what we're going to use is the replacement of sine squared with 1 minus cosine squared of x, or obviously we can do cosine squared is equal to 1 minus sine squared of x. So it's just a slight manipulation of that product. So that's Pythagorean identity, right? So let's go ahead and put that over here, Pythagorean. And this is on your formula chart. You also have 2 power-reducing identities that we haven't really looked at all so far this year, but we haven't looked at much at all, even in your pre-cal course. So this is a power-reducing identity, and the idea is if you have cosine of 2x, that is the same as 1 minus 2 sine squared of x. So this identity can be used to manipulate this sine squared. So we would have to do a little bit of subtraction and a little bit of division. And what we would end up with is sine squared is going to be equal to 1 minus cosine of 2x, and then all of that would be divided by 2. We call this a power-reducing identity because we can reduce sine squared into something that is not squared. So that's one of them. Then the other one is the same beginning setup, but this is going to end up reducing cosine squared. So this is the identity, but then again, if we do a little bit of replacing, a little bit of algebra steps, right, add the 1, divide by 2, we end up with cosine squared equals 1 plus cosine of 2x divided by 2. So these are what we call power-reducing formulas, and we'll get to those here in a minute. Power-reducing identities. We want to be able to rewrite that squared. So let's start here with the idea of working with odds. So anytime we're dealing with an odd power of any kind, whether sine is on or odd, whether sine is odd or cosine is odd, it doesn't matter. We're basically looking to kind of save one of the sine factors or save one of the cosine factors. We want to separate if we're dealing with an odd power and then replace using one of these identities. So let's do example 1 so you can kind of see what I'm talking about. Notice that cosine is cubed. I don't know how to integrate that by itself, but what I can do is I can break it up into pieces. So I can rewrite this as cosine squared of 5x times cosine of 5x. Now the cosine of 5x is the piece that I want to save. So I want to save this, but the idea is I know that the derivative of sine is cosine, and the derivative of cosine is negative sine. So if I can replace this with something having to do with sine, I'll probably be able to manipulate this into a u sub scenario. That's what I'm trying to get to. So what we want to do here is we want to replace, here, we're going to convert using the Pythagorean identity. So when we rewrite this, we're going to have 1 minus sine squared of 5x times cosine of 5x. So knowing that, I can take a moment to do some u sub. So because this is a product, basically this is distributing through. Now, you don't have to distribute it through. I wouldn't necessarily recommend that. But if I was to distribute this, the sine squared and the cosine, that is something that I would know how to integrate because I could u sub my way out of it. And just integrating cosine would also work. So when we're dealing with a product, we can go straight to u sub. We can say that u is going to be the sine of 5x. Now, be careful with your chain rule. The derivative of sine is cosine, but you do have to multiply by 5. So cosine of 5x dx. So when I rewrite, I'm going to have an extra 1/5 whenever I do my replacement. So be careful with that. So notice that this is now going to get replaced with u squared. This is going to be 1/5 du. Now you still have a 1, and we want to pay careful attention to that because we don't want to get completely lost in that. I'm going to move the 1/5 to the outside. You're going to have 1 minus u squared du. That is something that I'm comfortable and familiar with in terms of integration. The 1/5 is on the outside. The antiderivative of 1 is just going to be u. And then the antiderivative of u squared is going to be 1/3 u cubed. Don't forget the plus c. And so now all I have to do is replace the u with the sine of 5x. I'm going to go ahead and distribute just in an effort to kind of see it a little cleaner. So sine of 5x there. And then you've got 1/15 sine cubed of 5x plus c.